Before I start, I better explain some of the terminology that we use because our language sometimes can be a bit different, and I'll probably lapse into English, Irish type of speaking. So when you talk about criminals, we say forensic scientists. When you say attorneys, we say lawyers. And the one that's particularly special to Ireland is we call our police the guards. And that comes from the Irish words on Garda Síochána, which means guardians of the peace. So if I lapse into that kind of speak, you know where I'm coming from. The other thing I want you to know is I can spell, but it's different spelling to your spelling. So just bear with me with that. I've been very impressed, because of the talk I was going to give, at the number of times that speakers have commented on the problem of evaluating the evidence. It's coming up day after day. How do we get past the could have come from phrase? It could have come from the same source. What do we do about that? It's even been suggested that the whole future of trace evidence depends on this. It depends on our ability that if we can't communicate it to the juries and to the courts, well then it raises the question mark about how we can continue with the science. I was at the workshop on evidence recognition and recovery on the first day, and Peter DeForest spoke about the continuum of physical evidence. And he made the point that we're very good at the middle of the continuum, and that's the bit when the stuff comes into the lab and we do our tests. Well, we have a lot more to do on the recognition of the relevant evidence at the scene of the crime, and we need to give more scientific attention to the end of the process, which is the evaluation and the communication with the legal people. And Claude Roux yesterday made a comment on that perhaps we need to worry less about the discrimination and focus on the value of the added information. Now, if you go back to what's our role, and I don't think anybody will disagree with this definition, that if we don't evaluate what our results means, well, how the hell can lay people do it? And that we have an obligation in this regard. Inman and Rudin will also say this, and say that it's up to us to furnish an accurate and complete interpretation of our results, and that this includes the limitations of the test and the evidence, the inferences we've made, the assumptions we've made, what the results mean and what they don't mean. And that's a tall order. How do we do this and keep the jury awake at the same time? Now, I'm talking from the aspect of our experience in Ireland, and I just, everybody, non-Americans, he's put up a map of where they're from. So I found one in my other slides. It's not a very good one, but the important thing is that we are not part of the United Kingdom. We're a completely separate country. But sorry, where's the pointer on this? Anyway, the top part of the country, Northern Ireland, as you will know, is part of the United Kingdom. So in the Republic, we have a population of about 4 million, and we just have one forensic science laboratory, which was established in the mid-70s. We have approximately the equivalent of 60 full-time staff, and we deal with 13,000 cases a year. Approximately 11,000 of those are drugs. Now, I'm coming at this talk from a perspective of a laboratory that has tried to engage with the issues of how we communicate the significance of our findings. It's important to say that I'm not a statistician. I'm not an expert in Bayes. And initially when I was asked to come here, I thought, I'm the wrong person here. But then I realized that, in fact, the practitioner's view is very important, that it's very easy for an expert to come along and have all the answers to the questions, but that it might be very valuable for you to see what a laboratory has done that has struggled with this approach. So I joined in the 1979. The lab was barely in existence. We had no standard operating procedures. We were very much in the dark. And the questions that came to us then are very much the questions that are still being talked about here nearly 30 years later. Should we know about the case circumstances? Is it going to bias us? Which tests should we apply? Particularly if we don't know the circumstances, we're going to end up doing the same tests every time. Does that make sense? Are we going to do them regardless of whether they're going to give any value? What do we do about courts' expectations that are unreasonable? Once there was any suggestion of legitimate access, that there was some explanation for contact, we didn't do those cases at all, even though sometimes the explanation was there was good reason why we should have. And of course, we just reported our findings back at it matched. We didn't even say it could have come from. So we struggled with this and found that there were a lot of cases where we were misleading the courts. So an example from the early days was a container filled with explosives that was found buried in the beach. And the container was manufactured from something that had been painted with 10 different coloured paints. The police went to the suspect's farm and found an oil tank that a piece had been removed from that had the same number of matching coloured paint. So scientists were delighted, wrote this off in the report. And then we were all surprised when the suspect wasn't charged, because of course the court had no idea what this meant, or our DPP who decides whether to charge or not. Again, another very high-profile case illustrated the problem to us again, and this was the murder of Lord Mountbatten in 1979. We were barely in the lab, and this case fell into our laps. He was a member of the royal family, a hero of the Second World War, who used to holiday in Ireland, and the IRA put a bomb on his boat, and he and 2 of his party were killed. Now, we were very fortunate in that the suspect was apprehended very quickly, and we found some paint fragments on the suspect's jacket that had 3 different layers of green paint and matched the green paint on the boat. Now, in this case, the scientists got plenty of time in court to explain the significance, how significant this evidence was, and the accused was convicted. Sometime later, the same scientist is in court with the same judge, who's really happy because he knows all about paint now, except that she has got single layer white paint. And he proclaims to the court, paint is very significant evidence. So the scientist has to go back to explain to him, well, not in this case it isn't. So this is what set us off on our journey on interpretation. And we began to realize that our nearest neighbours in the UK were beginning to produce papers and give talks on the principles of interpretation. And these are based on the fact that the relevant background information provides the framework within which the scientist operates, that we need to consider, at least 2 competing propositions. The importance of this is that it's quite clear, both to the scientist and to the reader or the person in court, what exactly we're evaluating, rather than a sort of a vague thing as if how significant is this. And finally, we need to observe the results. We have to ask ourselves, how likely are we to observe the results if the prosecution proposition was true and if the defense proposition was true? Now, I know some of you are saying, what on earth is she talking about? Just bear with me. Just have to do a little bit of terminology. The probability of the evidence, if the assertion is true, can be divided by the probability of it if it's not true, and this gives us what's called the likelihood ratio. And then just using the HP to illustrate to denote the prosecution hypothesis, which is the numerator on top of the line, and the defense hypothesis, the denominator. Now, the best way to illustrate this is actually to use a case, and this was a case that I worked on in the mid-90s, where a priest had been shot dead in a forest. I got really good evidence in this case, but I didn't know how to report it. The police felt that the priest had been abducted from his home and that the assailant had climbed in through the bathroom window. This was based on the fact that the bathroom window was open, the curtain was disturbed, and there was dust in the bath. And the priest housekeeper, who's a myth of a personality in Ireland, priest housekeeper, said that that bathroom was always pristine and there'd never be dust in it. So the investigator sellotape lifted the windowsill and brought us in the curtain. Suspect was apprehended some days later. He was living rough in the area. When we looked at his clothes, we found that he had gloves in the pocket, and don't seem to be able to get the pointer, but I think, can you see on the gloves that there's sort of a bleaching effect on the fingers of the glove. So we found, oh, thank you very much. Thank you. We found fibres on the windowsill and curtain that matched. I didn't know. I said, I don't know what I'm going to say about this, so I just said it supported the suggestion that this suspect, O'Donnell, had been in contact with the window. But nowadays, I'd go at it a different way. And I'd say the prosecution hypothesis is that Brendan O'Donnell climbed through the window wearing these gloves. A good alternative proposition to that is that somebody else climbed through the window. What's the probability of finding matching fibres if O'Donnell climbed through the windows wearing the gloves? Now, Bob has already referred to the fact that you can't realistically have data for all the different kinds of trace evidence. And even if we had done a study on the distribution of matching blue acrylics in the population, if we'd done it 2 years previously, it probably didn't apply at that particular time. But we keep talking about our experience, and we keep talking about what we've learned from our experience. So just consider this then. Sorry, I've moved on a little bit too fast. Before, the probability of O'Donnell going through the window, or if he went through the window, what's the probability of him leaving fibres? You've got to consider, would he have made contact with the window? Is it certain that he would have made contact with the window? No, it's not. He might have managed to climb through without making it. And would the fibres have persisted afterwards? So considering that, you're saying it's not certain that he'd have left them. So I'm giving it a probability of 0.7 or 70%. Then taking the defence proposition in relation to if somebody else climbed through the window, what's the chances of finding matching blue acrylic? Now, if you go back to, you're in the lab and you say, right, I'm going to look at the next 100 garments going into the lab, doesn't matter what kind of a case, what's the chances that one of them would have the same acrylic that matched these gloves? Would you say you're going to find it in the first 100 garments? You're not. Are you going to find it in the first 1,000 garments? Very unlikely. Would you find matching it in 10,000 garments? Maybe. So I'm going to be very conservative here and just take a figure, an estimate that the frequency of this type of fibre in the population is, if I say 1 in 1,000, I'm being very conservative. I'm actually underestimating my evidence. And you'll see how this works out later on. Then we look at frequency of bleach fibres. How often do you come across bleach fibres in your work? I'm going to make an estimate again that, and again I think it's a conservative estimate, that maybe 500 out of 500 garments, only one would show some sign of bleaching. So now I have two figures. So we put them together with the likelihood ratio. And when we do our sums, we find that the fibres are 350 times more likely if O'Donnell climbed through the window wearing these gloves than if somebody else climbed through. Now that is a way of expressing the evidence, and it's a lot different than saying the fibres in the window could have come from O'Donnell. We don't use the numbers in court. We use what's called a verbal equivalent, and this is a scale, a published scale that's used. Now, if you remember, I said moderate support originally in the mid-90s, and having looked at it this way, I knew that that was underestimating it. My gut instinct was it was very good evidence, but I had no way of showing an independent way of assessing that other than my gut. In Ireland, we talk about feeling it in your waters, and that wasn't going to go down very well with the court. So using this system, we could come up and we could say that the evidence provided very strong support for the suggestion that this suspect had been in contact with the window. So this is the format then in which we would actually write the report. We would state the alternative propositions, and we would then say the findings provide very strong support for the proposition that O'Donnell climbed through the window wearing the gloves rather than somebody else climbed through the window. The important thing here is we're not addressing the issue of whether O'Donnell climbed through the window. That's for the jury to decide. We're just addressing what is the probability of the evidence given the suggestion that he climbed through the window. And that's quite a subtle point, and don't worry if you haven't got it. It took me a long time to get to grips with this, so with that particular aspect of it. But believe me, it comes with time. And this actually very nicely separates out the role of the jury from our role as scientists, because one of the criticisms is if we go too far, are we usurping the role? But this very clearly says that if we look at our scientific evidence, it can then be handed to the jury. If we give a weight to it, it'll be handed to the jury and added to the other evidence that they have. So that's the basis of the Bayesian approach, which is expressed that in the sense of, or this is the expression of it, prior odds multiplied by the likelihood ratio, which is the bit we do, gives you the posterior odds. So the prior odds are the other evidence that the jury has heard, which we may or may not be aware of. It may not be relevant to us. Then they hear our evidence, but it's expressed in a way that they can add it or subtract it from the other evidence they've heard, and the posterior odds are then the conclusions that they come to on the basis of this combination of evidence. Now, it could be, you may say, well, maybe my alternative hypothesis in the Brendan O'Donnell case was the wrong one. Perhaps it might be better to say that the alternative was that nobody else climbed through the window. Well, I can examine that one as well. So here we have to start thinking about, well, if nobody else climbed through the window, how would the fibres get there? What's the frequency of fibres in outdoor surfaces? Now, a very nice paper has been published on a survey of this in Germany, and very interesting figures have come out of that survey. Most of the fibres found were natural fibres. Only 3.2% of the synthetic fibres were acrylic, which meant that about 0.5% of fibres in the outdoor population were acrylic. The other interesting statement from that paper was that when you get a collective, which is a group of fibres together that are the same, that this is actually quite a rare occurrence if you're looking at random in the outdoors. So this all pointed to the fact that even when using that alternative hypothesis, if you started plugging in the figures like I did, it would still come out as the very strong support that Brendan O'Donnell climbed through the window wearing these gloves rather than nobody else, rather than nobody climbed through the window. I hope that has illustrated that we tend to undervalue our evidence, and that this gives us a way of giving a closer value to the evidence that we're using, but and if we do it conservatively, it will still be somewhat undervalued, but it's still in safe grounds, and certainly better than what I was originally going to say. But this approach also has another very important aspect, and that is in relation to the inherent bias in the way we do our work at the moment. And I'm going to just take a hypothetical case: car chase, stolen car. Suspect is arrested a short time after the car crashes. He's found in a nearby street. He says, "No, it wasn't me." He's wearing a jumper that sheds. And here, the scientist looks at the lifts, the sellotape lifts from the car seat, from the driver's seat, and finds 4 matching fibres. How would you report that? Now, can we have a little bit of audience participation and see if you're awake? How many would take the first option as a way of reporting the findings? I know it's more the European side, so maybe not many people. How many people will say the fibres on the driver's seat could have come from the suspect's jumper? Yes, quite a lot. Would anybody say it does not support the suggestion that the suspect was in the driver's seat? No, right? Or anybody say that it provides no support for the suggestion that the suspect was in the... No, okay. Right, let's have a look at it using the Bayesian approach then. If the suspect had been in the driver's seat, he's wearing a jumper that sheds highly. Is it reasonable to expect that there would be a lot of fibres on the seat? Would anybody disagree with that? That we'd expect to get a lot of fibres? So the prosecution hypothesis then is we have an expectation of a lot of matching fibres. And the defence would say, well, my client didn't sit in the seat, so what would we expect then? We'd expect we wouldn't find any matching fibres, or we may find a few by coincidence. Well, what we did find, we found a few. Therefore, the findings support the defence hypothesis and do not support the suggestion that the suspect had been in the driver's seat. Now, how many of us, when we find unexpected evidence, actually have the courage to say that? I think it's quite difficult, but it's actually the true answer. Now, you may say there'll be other explanations, like he was sitting in the other seat, or he had been in contact with the driver, and when you say could it come from, which is it's accurate, but is it misleading? And will the jury understand what you mean? Whereas, in fact, it would have been much more realistic and fairer to have actually said it doesn't support the hypothesis that he was in the driver's seat. Now, there's a lot of constraints against using this approach. I mean, if it's the answer, well, why are so few of us trying to deal with it? And it's a very difficult area in the sense that the concepts are hard to get to grips with. Ian Evatt, who's one of the scientists who started this process of thinking, calls it the slippery slope concept. And I certainly, it still happens to me. I say, right, I understand this, and 2 minutes later it's gone. All I can say about that is that the more time you spend looking at it, thinking about it, and working with it, the less slippy the concept becomes. The lack of data and up-to-date data is a reason people say for not using it. I think I've illustrated how it can be used without hard data, but there are plenty of situations where data does need to be gathered, and I'll give an example of that, hopefully, if I have time. It can be time-consuming, but it can also save time ultimately. Some of you may be aware of the Prosecutors Fallacy. It was mentioned earlier. I don't have time to go into it, but again, it's a problem that can be overcome. And finally, how do we communicate our findings to the court? And Bob Coons was already talking about how to communicate his type of findings. That's difficult. Communications between scientists and legal people is always difficult, no matter what we're trying to do. So there's nothing new in that. There's a very interesting book written on this topic by Robertson and Vigneault, and they maintain that part of the problem of the communication between scientists and lawyers is we're using the wrong language, and this approach gives us the language with which we can talk to lawyers and they can understand us, because we're moving away from the technical stuff and we're moving into a logical and inference process. And that, in fact, that this approach is what distinguishes forensic science from other sciences. I want to give you an example of collecting data. In Ireland and in the UK, we use mini-tapes to collect gunshot residues. Now, I've been making inquiries, and I think a lot of you use stubs, but these are just pieces of acetate with a double-sided tape at one end. We take off the cover and then just sellotape lift the clothing with these mini-tapes. Now, a guy in Scotland, in a lab in Scotland, discovered that these are very good for collecting DNA evidence, for collecting epithelial DNA. And we've all started using it, find it increases sensitivity considerably, and it's much easier to process than lumps of fabric. We started getting amazing results in sexual assault cases. Any biologist here will tell you that most sexual assaults we actually don't find semen. Our figure in Ireland is only 45% of our cases that we find semen. So what do we do? And on the basis that if there isn't semen there, but there's been intercourse, that vaginal cells might transfer from the assailant's penis to the front of his underpants, we've been cutting up the front of underpants and looking for DNA. With the mini-tape, the results are astounding. We frequently find the female DNA on the male's underpants when he has denied intercourse and when there's no semen. The problem was, if that was fine when you had a case where the guy said, I was never near her, and but when there was legitimate non-intimate contact, which is very frequently the case in this type of situation, they've been at a party together, they've been holding hands, what's the likelihood of this evidence appearing on the man's underpants if he didn't have intercourse? So I'm part of a group in the UK and Ireland, which is known as the Body Fluids Forum, and we're trying to accumulate or develop some information on this so we can apply the Bayesian method. And what we're just starting it recently, but one of our labs is setting up a trial, first of all, to maximize the possibility of transfer by secondary transfer. They screened the women in the lab and found one that shed very well. And then they had a very enthusiastic male volunteer who came into work, had a shower, put on a brand new pair of underpants, and then had to spend 2 minutes in contact with this lady, either by stroking her face or holding hands, and he gets paid for that. And then he comes the work bit, because then he has to go off and simulate urination, and his underpants are taken and taped. And our early results are indicating we're getting full female profiles from the underpants. So this is an ideal situation for the Bayesian approach, but we need an awful lot more data before we can use it. So we're going to extend the trial to other situations. Now, the information that we're looking at is going to feed the denominator, which is what's the likelihood of transfer of female DNA to a man's underpants if there was non-intimate contact. We also need to look at the numerator, which is what's the likelihood of female DNA transferring to the man's underpants if he did have intercourse. Now, that's going to be much more interesting one to set up, but we're not sure about volunteers. So if anybody on this side of the Atlantic would like to join in, you're very welcome. So just to wrap up then, these are the issues that we need to consider in evidence evaluation. One part that I possibly didn't emphasize was the second last one there is that we have to make it quite clear to the court that if the circumstances we understand if there's any difference, we will have to reevaluate our findings. So we have to go right back to start and say, right, the different circumstances, and that has to be made very clear to the court. And where we are in Ireland, I don't want to give the impression, because I probably have given the impression that we're doing this all the time. We're not. We're still in the very early stages. We apply this approach to a small number of cases. Now, we do use a scale all the time, which goes from no support, slight supports, up to very strong supports, but we haven't necessarily applied the alternative proposition, which strictly speaking we should have. And last year the scientists started to put in their pertinent understanding of the circumstances into the report. And next year, or this year in fact, before the end of this year, we're going to start doing a pre-assessment of some cases before we actually start to see what our expectations are and hopefully then be less biased. So the question really I'm raising to you is this journey worth undertaking? It's not an easy journey. I think if it was an easy journey, if it was the problem of how do we get away from the phrase, could it come from? If it was easy, we'd have done it a long time ago. I think we have to accept it's going to be difficult. But we have to find a way that is easier for the jury and for the lay people, where we can communicate with people. And the more I look at this method, the more I'm convinced, and the more the other senior managers in our laboratory are convinced that this is the way forward. And basically, we can't see an alternative to this. So thank you very much for your attention.